This example will be demonstrated in modeling a deep cantilever beam. This beam is composed of two different cross-sections as a three-dimensional and beam element. We will compare the results between solid and beam elements for the vertical and horizontal load. Firstly, the step-by-step procedure for beam elements will be discussed for the OpenSees platform. The post-processing will be done by the FeView tool. Step 1, Model Builder. This command is used to define spatial dimension of model and number of degrees of freedom at nodes. NDM represents the dimension of the problem. It can be 1, 2, or 3 for corresponding 1, 2, or 3-dimension problem. NDF refers to the number of degrees of freedom at the node. For example, for a 3-dimensional frame, it will be 6, and for a 3-dimensional truss model, it will be 3. This slide also shows the unit system used in the entire. Step 2, Nodes. This command is used to construct a node object. It assigns coordinates and masses, if needed, to the node object. The figure at below shows the nodes and its coordinates. Step 3, Supports. Fix command is used to construct single-point homogeneous boundary constraints. Step 4, Geometric Transformation. The geometric transformation command is used to construct a coordinate transformation object, which transforms beam element stiffness and resisting force from the basic system to the global coordinate system. Available geometric transformation types are linear, delta, and corotational transformation. Step 5, Elements. This command is used to construct an element and add it to the domain. Here elastic beam column element is used. The calculation procedure for the section parameters are presented in this slide. Material properties also presented here. Step 6, Construct rigid link. Assign rigid link between node 5 and node 6 to connect the two sections of the beam. Step 7, Apply load. Assign vertical load at the free end, node 12, by plane load pattern. Similarly, we can apply load for any directions. Step 8 and Step 9 explain the recorded and analysis setting. Current version of FeView compatible with node results only. The file name and output type for each recorder should be as FeView requirement for the post-processing in FeView. Open the TCL file in FeView tool for the post-processing. TCL file can be edited through TCL editor. Run the model. Then you can get your rests as follows. For more information, follow the FeView manual. For horizontal load, change vertical load to horizontal load as follows. Similarly, three-dimensional solid element model is generated using the standard brick element. And finally, the comparison is done. This slide shows the comparison for displacement. The results can be varied due to mesh size. Here maximum mesh size is used for beam and solid elements are 1 and 0.5 meter respectively. The TCL files can be downloaded by the link provided.